Hello students, welcome back. So now I'm going to show you how to plot scatter plots and line plots. I'll also show you some of the customization techniques like how do you put markers, how do you change the line width and so on and so forth. Also, how do you label the x-axis and y-axis, and also how do you add title, how do you put a legend. I'll show you all this in this session. Also, I'll show you how you can plot an equation of a curve. Let's say equation is y equal to 5x squared minus 3x plus 1, and you want to plot this. I'll show you how to do that. I'll also show you how you can read the data from a CSV file and plot it. Okay, so let's get started. The first thing you want to do is make sure your matplotlib is installed. So when you run this thing, if you don't have matplotlib installed, this is going to take anywhere between few minutes to like maybe 5 to 10 minutes, depending on the speed of your computer and speed of your network. Okay, in my case, I already have installed, so this should be pretty fast. And there you go. So see, I say requirement already satisfied because I already have this thing installed. Okay, so let's import our libraries. I import my matplotlib by pyplot as plt. I create an alias for that. So let's start with the scatter plot first. So let's say you have this data. You have age and weight of somebody. So this guy, his age is 20 and his weight is 40. Another guy, his age is 25 and his weight is 55. The third guy, his age is 50 and his weight is 60. And you want to plot that. So this is my x point. So x point is going to be my 20, 25 and 50. So this is my x point right here, and likewise my y point would be 40, 55, 60. That would be the 40, 55 and 60. This is my y point. And then all you have to do is just call this inbuilt method scatter. You say plt.scatter, you give your x values, your x point, and supply your y points as your parameter, and then you render that by calling plt.show. That's going to display your graph. So when you run this, you can see that this is how your graph looks like. Let me make it a little smaller so you can see that. So it is displaying the 3 points, first, second, and third points right here: 20, 40, 25, 55, and 50, 60. All right, now let's say you want to put a different marker now. In this case, by default, it's giving you this circular marker, this round marker. I don't want that. I want my own custom marker. So I want this star marker. You can do that too. So this is the same data. In this case, I'm just saying plt.scatter right here. And I'm specifying this extra marker line right here. So when I run this, it's going to give the star as a marker. By the way, there are different markers. You can also use O, you can also use plus. So if I change this to plus right here and I run this, it's going to give you a plus marker. So there's a lot of list of markers. You can actually look at the documentation right here. Let me just show you. And there you go. These are a list of the markers. So it tells you if you want to draw a point, you use this right here. If you want to draw this marker, then you have to use this symbol. If you want to draw this symbol, then use two. So you can actually go through this official matplotlib documentation and see which one actually you want to use for your purposes. Okay, what if you want to change the colors? So far by default it's giving me kind of like bluish color. Okay, and maybe I don't want this color. I want my own custom color. So same data points, x point and y point, and I'm calling my plt.scatter. Supply your x point, supply your y point, supply your marker, and then you give your color equal to orange right here. So in this case, it's gonna plot this using orange, and you can see that this is orange now. If you change this to something else, let's say black right here, black, and let's run this, and there you go. You can see that it changed back to black. So let's change it back to orange, and let's run this, and there you go. It changed back to orange. All right. What about the figure size? So by default, it's giving me this big giant figure. Maybe I don't want this big figure. I want my figure to be smaller. But Matplotlib does give you the option. There's an inbuilt method called figure. And in this figure, you can actually specify your figure size like this over here. So 4 will refer to the length, and your 2, this one refers to the width over here. So in this case, I'm saying give me a figure size with 4 comma 2, and then you plt.plot. Call this plot again. Everything is same except I just added this part right here. Okay, so let's run this. And now you can see that this is your picture. And if you look at your figure, it's a lot more smaller than this picture, this figure right here. And that's because I changed my figure size to something smaller. So now I want to plot the graph of two different pairs. Suppose I have Alice's score, study hours, and the scores Alice obtained, and likewise Bob's study hours and scores. So Alice, she studied for 2 hours, her score is 50. Studied for 3 hours, score is 55. Studied for 4 hours, score is 58, and likewise for the rest of them. Same thing with Bob's. Bob studied for a certain number of hours, and these are his corresponding score right here. I want to plot these two. Well, you can do that too. That's easy. So let's call those plt.figure. I'm specifying my figure size is 5 comma 5, and in this case I'm calling my scatter, and I'm supplying I'm actually calling scatter twice. I'm calling it once over here, twice a second time over here. The first one when I call, which is right here, I'm giving Alice's data right here. So you can see that Alice's data, and then I'm giving my color for green. So Alice's color is going to be green, and I'm also using a special marker for Alice, which is my O. Likewise, I'm doing the same thing with Bob. I'm giving Bob right here. I'm giving Bob the color magenta. I'm giving marker as S right here, and then I'm rendering it. So when you plot and dot show, when you call the show method, this is going to show for green would be your Alice and your magenta would be your Bob. So this is your Alice right here, and this is your Bob. Okay, but maybe I don't want this. Maybe I want a little bit more prettification. I just want to make it little bit more better, and I can do that. So I can add some labels and display it. For example, if you look over here, there is no label out here. It does not tell you what y-axis is. It does not tell you what x-axis is. It doesn't tell you which one is green, which one is magenta. It would be nice if you can label this, put some type of like legend over here, or you can put some type of title. That'll be nice. And Matplotlib does give you that option. So now I'm going to do that. So this is my Alice's study hours right here. This is the Alice scores. Likewise for Bob study hours, and this is the Bob score. Calling the same function figure size, calling this plt.scatter, and now I'm adding this part right here. This part is responsible for prettification. Think of this as my own customization. So let's go through this in each one of them. X label. This is saying that in my x-axis, use hours studied as my x label. For my y label, use test scores. Likewise, title, I want to be called as relationship between study time and test performance. Legend. Now, this one is responsible for putting this right here. Okay, that's what legend does. This legend actually gets its value from here, label. So now I'm giving a label right here, label equal to Alice and label equal to Bob. So when you call this legend will put the label out there. Okay, grid equal to true. So this is responsible for putting these little lines. So this way you can see where your numbers are. Can I help you in visualization? Then I'm putting my y limit 0 to 100. So I'm basically saying that put all my y-axis goes from minimum 0 all the way up to 100. Likewise, you can specify your x limit. You're saying your x, you wanted to go from 1 to 9. And this will be going from 1 all the way up to 9. Okay, so there is that, and then you just render it. Plt.show, you call plt.show, and that's going to render that. And you can see that it prints out and displays this picture right here. If I remove, let's remove some of them. Let's say you remove the legend right here. So the moment I remove legend, I disable this line, and if you come down, you can see that legend has gone. Okay, what if you disable the grid right here? So when I disable the grid, you're going to see all these lines disappear. And there you go. You can see that line has disappeared. So let's go back, put our grid again. Okay, and let's put our legend again, and let's run this, and there you go. You're gonna get your legend right there, and now you can see your grid. Now I'm going to show you how you can plot an equation curve. Suppose the equation is y equal to 5x squared minus 3x plus 1. And we want to plot this. So if you remember from high school math, anytime when you plot equations like this, you need your x and y values, right? You pick up an x value and then you calculate your y using this, and this way you plot your x and y. So let's do that. So I'm importing my numpy as np. Make sure you have numpy installed. What numpy is responsible for? Generating data sets. So in this case, I'm generating 30 data points. So this 30 is responsible for generating 30 data sets or 13 data from -4 to +4. So I generate these numbers from -4 to +4 and generate 30 points. And then I print those values of x out. And then after I do this thing, I calculate the value of y. So in this case, this is going to perform a vectorized operation. So my y is going to be equal to 5 times x squared minus 3x plus 1. And then I print the value of y. So as you can see, this is my x. It goes from -4 to +4. And when x is -4, your y is 93. When x is minus 3.72, your y is 81.5. So all this calculation for y is done by this equation right here. And as you can count over here, this is going to be total 30 points between -4 to 4. Okay, so I got my x now. I got my y value. And let's plot this now. So in this case, what I'm doing, I'm actually just rewriting the same function twice, right? This, okay. And then I'm just calling this scatter, and then I'm supplying my x and y, and marker I'm using this dot right here. And then you render plt dot show, and that's gonna plot. Oh, what has just happened? All right. Oh, let me run this cell first. Now come down and let's run this cell, and there you go. So now you can see the scatter plot right here for this curve, and there are approximately 30 points. Not approximately, actually there are exactly 30 points. You can actually count from here to here. That would be from -4 to +4. That's what your x is. It ranges from it takes these values as your x is changing, your y is also taking different values depending on that equation. Okay, what if you want to read from a CSV file? You can do that too. So in this case, I'm importing my, don't really need this. So let me just, oh, what just happened over here? All right. So now let's just import our pandas. So in this case, I'm using pandas to read my CSV file. And then I'm just printing few records out over here just to show you. So this CSV file contains date, sales, expenses, and profit. Right here, I want to plot that. So let's say I want to plot the curve between sales and profit. You can do that too. So in this case, you read your CSV file right here, then you find your x value. My x is going to be sales column, and my y is going to be profit column. And then you just call plt.scatter x comma y. So this scatter is responsible for plotting these scatter points. And then you also, I'm putting some x label and y label. My x is going to be sales, and my y is going to be profit right here. And then you render it plt.show. When you run this, it's going to generate these graph, this particular image for you. Okay, let me make this thing smaller, and now I hope it's visible. You have sales and you have profit, and you can see that as the sales is increasing, you see that the profit is also going up. All right, now I'm going to show you about line plot. Okay, now suppose I have these same points 20, 40, 25, 50, and 50, 60. So this is age and this is weight. I want to draw a line plot. What basically line plot is, it's going to connect the dots. That's all it does. So in this case, I'm just calling this plot inbuilt method and supply your x and y. You render it and you can see that it actually connected this point with this point and this point right here. That's all it did. Okay, let's add markers. Maybe I want to see the markers. So in this case, my x is same value as previous one, right here, x and y, and then plt.plot. And then I'm supplying this marker equal to x. There are other markers too, like dot, plus, o, d. Try each one of them and see what it gives you. So in this case, I'm creating marker equal to x. When I run this, it plots out these lines. And as you can see, there's a marker over here, there's a marker over here, and there's a marker over here. Okay, what if you want to use some other style? Maybe you want to have like marker and line and color all at the same time. So matplotlib gives you that option. So in this case, you supply your marker. So in this case, my D, which is for diamond marker, and I want my line to be hyphen dot right here, and G stands for green color. So this is going to draw this line for me, this line plot. And as you can see, it actually draws diamond shape. That's what this D stands for. And this hyphen dot is the is this is how your line looks like, and G is for green color. By the way, don't have to remember all this thing. You can actually go on the matplotlib documentation library and just type like, give me the actually, let me just show you. If you can just come over here and well, let's see, just go to Google and just type matplotlib docs. Okay, doc for which one was it, plot. All right, and there you go, this is the one. Click on this and you can go through each one of them. So you will find all these options over here. So it tells you like how you can actually draw each one of them. Somewhere over here you'll find all those colors. So if you go down somewhere over here, let's see, where is that? Yeah, there you go. You see that format, marker, line, and color right here. So it's telling you like if you want all these types of format, you can do this way. And yeah, so make sure just go through this thing. And this is the one they actually, anytime when they make some changes, they keep that updated. All right, so now what if you want to change the marker size? So by default, it's taking some marker size, which are it's taking some default marker size. Maybe I don't want that. Maybe I want to have a bigger marker size. So you can say ms equal to 20. That's your marker size. So marker equal to O, and my marker size equal to 20. And when you run this, it's gonna create these marker size. Look at that, how big they are. Okay, what if you want to change the line width? Okay, you have this line and maybe you don't want this, you want a little bigger. You can do that too. So line width equal to 10.5. I'm adding just another line width. When I run this, you can see that marker size is big, which is 20, and line width is 10.5 right here. Okay, so let's say you want to plot date versus profit. You want to do the line plot. So I'm reading my CSV file. This is the data over there. And this is my date. My X is going to be my date column, and Y is going to be profit column. And I call this plot. Okay, in this case, I'm using marker as star. Then I'm changing my X take to rotation. I'm making 45-degree. Well, let me show you if I don't do this thing first. So X label is sales and Y label is expenses right here. Okay, so let's see. Actually, this should be date. This should be date right here. This is my X and my Y is profit right here. and profit. Okay, so let's run this and come down over here, and you can see that. Now look at this date right here, all hodgepodge, all mixed up together. And that's because this date, if you scroll up a little bit over here, is basically a long date, right? So that's why it's all hodgepodge. So this is a little trick you can employ. You can just say plt.xtext, and you can specify your rotation equal to 45 degree. And what this is going to do is going to take these text character, is going to rotate by 45 degree. So let me run this now and come down, and you can see that now it's 45 degree. You see that 45 degree, each text has been rotated by 45 degree. This way you can see every single values for x values over here. Okay, so what if you want to plot two equation curve? You can do that too. So let's say you have y equal to x square and y equal to minus x square. So we can do that too. In this case, import my numpy as np. So generate some x points. So let's say my x is from minus 1.5 to 1.5, and generates 30 points. So it generates 30 points for me. So this is my y1. That will be y1 equal to x square, and my y2 is equal to minus x square. And then I'm calling this plot. So I'm calling plot for x comma y1, and I'm also calling plot for x comma y2. I want b, which is blue line, and my line I want to be hyphen. This is my g line, which is green, and my line to be hyphen. Then I render this. When you render this, you can see that you have two plots. This is your first plot, y equal to x squared, and this one is y equal to minus x squared.